Rain Access Solutions.
Hi, I'm Glenn of Rain Access Solutions. Welcome to my vlog. Welcome also to my C#.NET tutorial for beginners, and we are now at lesson number 16. In this episode, we're just going to go back to our last lesson number 15, and we're going to do a little recap. In our lesson number 15, we brushed off the introduction to LINQ. Let's run the sample. And in this LINQ query, we had a list of number from 1 to 9, and we use both type of LINQ query, which are the SQL type query and the method type query for querying the list. And here was the output of that example. Now, I just want to clarify or give a more clearer picture of the parts of the query so we can dive deeper and understand more of its syntax. Without further ado, let's proceed. This is the declaration for creating a list in C#.NET. We are declaring a list called numbers, and inside that numbers we have the series of numbers ranging from 1 to 9. And here is our LINQ query, which has a method type syntax. Okay, so the generated list has a structure similar to this. If we create a table version of the list, here is how the structure should be. So in this example, the column for value and index are in any order. The index could be on this side, on the left side, and the value could be on the right side. Okay, on the left column, we have the assigned values to each element that are from 1 to 9. And on the other column, we had the assigned index or indices starting from 0 to 8. C# is a zero-based indexed type, so all the indexes in C#.NET should start from 0. Now let's break down the syntaxes from a method type LINQ query, starting from the myNumbers. The myNumbers in this query is the result of the LINQ query. This entire LINQ query will have an output of this result. Now you may notice that it is very similar to the structure of the list. That's because we have actually extracted all the numbers, even though we used a filtering in the where clause. But if you notice, all of the numbers in the list are below 20, which corresponds to the criteria inside the where clause. Here we are filtering all the numbers below 20 or less than 20, hence our result. Now the LINQ query in C#.NET is a deferred execution, meaning if we do not call the value of myNumbers, this query or this LINQ will not be executed. Until then, it is just a plain statement. But once we call out the values of the objects inside the myNumbers, then the whole LINQ query will be executed. We can call the values from myNumbers by running a for each loop or writing a string join. Either way, this LINQ query will be executed, hence it is deferred execution. Okay, the next part of the method query that we're going to check is the word numbers. So the word numbers is actually this numbers here, which is the number of the list declared earlier. And if we look at its structure, we can define it like what you see in this table. We have the index here, and under the index column, we can see all the elements and their corresponding numbers. These numbers is actually the object that holds all of this data collection or list. Suffice to say, without this list, the whole query will fail, and it will not have something from where it should refer its data. The next thing that we will check from this query is the select clause. Now in this select clause, I'm just going to point out that in a method type query, each clause like the select or where should always have a lambda expression. If you go back to lesson number 15, we have discussed a bit about the lambda expressions. So this part here, starting from the end output, which is highlighted by a purple background, up to this index word, is part of the lambda expression. And this symbol here, the equal sign and greater than sign, is the lambda operator for the lambda expression. The end output is a variable that represents each element in the original numbers list. Here, we're actually selecting each of the element from this numbers list. And the index is the index number or the indices of this each element. Now, since this is a lambda expression, again, the left side is for the parameters of the select, and the right side or the right part of it is the anonymous object, which will absorb the value of these two variables from the left side. Hence, this arrow is pointing here. The end output will go, the values of this will be assigned to this, and the index will be assigned to this. When you see a word new followed by curly braces and a few variables in C#.NET, then it may mean that this is creating an anonymous object. And in the case of LINQ method query, when you create or when we use a select clause and create the lambda inside that clause, it will create an anonymous object here. When we say anonymous, there are no particular name for that newly created object, and each reiteration of the select clause, new anonymous objects are created here. If the conditions of this query is to get all of the items, if we filter all the result of this query to get only numbers from the list which are lower than 20, then this LINQ query will create 9 different anonymous objects. As you can see from here, we have the anonymous object 1 with a value of 1 and index 0. And we have the anonymous object 2 with a value of 2 and an index of 1. And it goes all the way to 9. If we think about it, the query is actually creating 9 different independent anonymous objects with true to properties. How does this where clause figure out each of these anonymous objects to be in the same group? All of these anonymous objects are part of the anonymous object list. Even though they are different from each other, and each of these anonymous objects are new instances which are independent of each other, they are still treated by the query as one collection, and in this case a collection of anonymous objects. Anonymous object 7 belongs to the same group as the anonymous object 1. Next is the where clause or the filtering part of the LINQ query. Here we assign the n-number variable to be the temporary name for the anonymous object. So when we create those anonymous objects, it doesn't have anything but it has a parameter or property called output. We also have another lambda expression, and what we're trying to do here is to give a temporary name or arbitrary name for each anonymous object that we have been selecting from this line. Okay, on the third part here, which is another select clause, we specified again the same name as the variable from the where clause, which is the n-number. The difference is that this n-number here represents each anonymous object that has passed through the where filter clause. It is just projecting new output from these two output. Of course, we can name the variable that we have assigned here or the parameter to a different parameter, and in this case I actually rename it to indifferent and it will still work. So here it can be any name. This is a typo, so sorry for that. Again, as I've said earlier, each of these LINQ operations, the select, where, or another select, will have different or independent or each lambda expression. Okay, to summarize the whole thing again, this part here creates the list, and here this is the whole LINQ method query type, and the my numbers here is the result of the actions that will take place when this method query is executed. The output will certainly have this value because of the filtering. Okay, the numbers in this part of the query is the name or the object that holds all of the elements in this list, as you can see from the table structure here. Now the n output, these two here, the n output and the index parameters of the select clause will represent each element in the original numbers. So here, whatever value that these two represent from the list will be transferred to these names here. And this part here is declaring or creating new instances of anonymous objects here. an anonymous object with two properties. So we have here anonymous object 1 and on2, and they all belong in the same group. The n number in the where clause, which is highlighted by a yellow color, is a temporary name for all the anonymous objects created by the select clause. Okay, so that's it for today's video. I hope we learned something from this tutorial. And if you find this video useful, please hit that like button, leave your comments at the comment section below. While you're at it, please subscribe to my channel. Thank you very much for watching. Have a nice day everyone. Goodbye.